determining earliest start times, latest completion times, the critical path, and slacks for a project. If we analyze a project and we find out all the activities that the project requires, the durations or processing times for all of those activities, and precedence relationships, we can create a network representation of the project with activities represented by nodes of this network. So here we have 10 activities for our project, and we see the identifications of the activities, the symbols representing activities A1, A2, and so on up to A10. And we also see here time or duration that each activity takes in days in this case. I'm going to, I created these nodes with additional spaces where I'm going to put some values, and the values will mean earliest start time. In this cell, there will be earliest start time for each activity, measured in days from the beginning of the project. This will be earliest completion time, and then the bottom parts, the corners will have values, latest start time and latest completion time. And in addition, we will put here something called slack. So the slack, we will define it later, but these are earliest start times and latest start times, and the same thing for completion times. Now, if you use a software for managing projects, the earliest and latest start and completion times will be usually expressed in days and hours from a particular date that you designate as the starting date of the project. However, here for simplicity, rather than putting dates, I'm going to put a number of days from the moment we begin the project. So I can actually say, in this case, that this will be 0 days or day 0 of the project, right? 0 days from beginning the project, and then it will finish 9 days from beginning the project, right? So the meaning of these numbers is how many days after we started the project this activity is started or completed at the earliest, right? Remember, these are earliest times. So, right, activity 2 can be started 9 days after we started the project and finished 12 days after we started the project. For simplicity, I will just say this is starting on day 9 and finishing on day 12. But remember, it really means how many days from the beginning of the project. So A3 can be started on day 12 because A2 is finished. And then this will be finished on day 23. Now, if I want to go to activity A7, you will realize that I cannot process it because activity A7 has 2 predecessors. You have to see all the arrows. It also has a predecessor A6. And we cannot determine the earliest start time before we know how soon A6 can finish the earliest completion time here. And this one in turn depends on A4. So the calculation that I'm doing is a forward pass, and in a forward pass, we have to first consider the predecessor before we consider successors until we reach the last activity. So I have to go back to A4 here and write here 12, right? Oops. And then the finish time of this will be 19. Then I can consider A6 start on day 19 and finish on day 25. And the same I can consider activity A5, start on day 19 and finish on day 27, right? Where 27 is, of course, 19 start and plus 8 duration. Finish will be on day 27. 19 plus 8 is 27. Now I can consider A7, and this, notice, I have to start it after I finish A3, but also after I finish A6. So if you were to tempt to put here 23, right? But this is the earliest start time, meaning minimum start time. You might be tempted to put minimum value of those 2. However, starting this on day 23 would not be feasible because, right, this is not allowed because on day 23, A6 will definitely not be finished. A6 can be finished on day 25. So that means 2 days later than 23. So the interesting thing is that the earliest start time has to be calculated as a maximum, not minimum of those values, right? It has to be maximum of 25 and 23. So it has to be 25, right? So once again, the confusing part might be that earliest suggests you want a minimum value, and indeed we want a minimum value, but we calculate it as maximum of completion times of the predecessors. So this will be 25, right? And then finished on day 46. And then this one, notice it has three predecessors, A3, 23, A6, 25, and A5, 27. So again, I have to take maximum 27 because this activity can be started only when all three are finished, and the earliest time when all three are finished is maximum of 23, 25, and 27, which is 27 plus 10. This is the finish time of this, or completion time will be 37. Then this can be started on 37 plus 15, it will be 52. And then this one again has two predecessors, 46 and 52. Maximum of those is 52 plus 5, it's 57. So what we can already say is that because we have one activity that's the finishing activity, so when this activity is done, the project is done. And in fact, this was some kind of final report from this, this project, right? So we can say already that the earliest project completion time, right, is, we can say the earliest project completion time is 57 days, right? We can finish this project in 57 days. But we still don't know a lot why this 57 days is right, why we took 57 days, and what is the reason we couldn't finish it earlier, although you can already have some idea because when we were taking those maximums, we were following a certain path, right? Now, what I'm going to calculate is the latest times, but latest times have to assume some kind of deadline. So I'm going to assume the deadline is 57 days. The earliest completion time is also the latest completion time for the last activity. And notice if I had multiple finishing activities, like there would be another activity, A11, which doesn't have any successors, then I would also have to consider maximum of their values as project completion time, right? And then I would put for each of them latest completion time. I'm going to use a different color here, 57. Latest completion time 57 minus 5, then latest start time has to be 52. It happens that it's the same. Start and, earliest and latest times are the same. But now when I go backward, right, this activity, I see what's the latest I have to finish this? Well, I have to finish before this starts at 52. So this at the latest can finish and day 52. Minus 15 is to start at the latest on day 37. And right again here, 37, because we have to finish before 37 minus 10, 27. But here, if you go here, you'll see that the latest we have to finish it is before day 52, and it's different than earliest 46. 52, and this one is 46, and 52 minus 21 will give us 31, right? And the same thing here again, if I'm considering, let's say, this activity, I have to have all the following activities. There's only one, so I'm just taking 27 from it. Minus 8, it's again 19. But here, 27, right? There's only one following activity. No, sorry, there are two. So here, this activity has this follower or successor and this successor. So now I can consider activity A6 because I have considered A7 and A8. And now what do I have to take? How late can I finish this? Can I finish this on day 31, taking the maximum, or 27? If I finish this on day 31, then there would be an overlap between A6 and A8, but A8 requires some data from A6. So finishing it on 31 would be too late. I wouldn't be able to start this activity on day 27. So I have to choose here minimum. So what I want you to see is that we're doing now a backward pass, and latest completion time is the maximum value of the completion time. It's actually calculated as minimum of start times, latest start times of the successors. So when I'm calculating this latest completion time, I have to look at start times of successors, 31, 27, and take minimum of them. So I'm taking here minimum 27 7, minimum of 27, 31, and then minus 6, it will give me 21. And again, you see it's different, right, in this example. So sometimes it's the same, sometimes the latest is different than earliest. Again, here I have two followers, 31 and this one 27, actually the same two as for A6. So again, minimum of them will be 27 minus 11, it will give me 16, right? And then I can go back to this. I can't consider this activity now. This follower is done, but this follower or successor is not yet finished. So first this, it's a backward path going from the end back to the beginning. So here, minimum of 21 and 19, this needs to be 19, minus 7 will be 12. Again, earliest and latest are the same. And here, minimum of 16 and 12 is 12, minus 3, 9. And then this 9 minus 9 becomes 0. And it's very important that this number right here should be 0. As we started from 0 and went forward, the reason we ended up here with 57 days is the same reason that makes us go back to 0 when we start from 57 here and move backwards, right? It's the same reason. So this should be 0 again. We start from 0, we end up with 0. So we calculated earliest start and completion times, and now we calculated in the green numbers is latest start and completion times. So what we can now calculate is the difference between the latest and earliest values. So when the difference is 0, we put slack 0. Slack means how much freedom or how much flexibility, how much can I delay this activity without delaying the whole project, right? If I want to finish in 57 days in the earliest project completion time, how much can I delay activity A? 1. And because the difference between earliest and latest is 0, the slack means I cannot delay this activity. If this activity is started one day too late or it takes longer by 1 or more days, then the whole project will be extended by the same amount of time. Here the same thing, 12 minus 12 or 9 minus 9, it's always the same difference. This will be 0. Here, 0. But here, 27 minus 23 is 4, or if you like, 16 minus 12, it's also 4. So slack is 4. Here, slack is 6, right? Here, slack is 2. Here, 0. Here, 0. Again, here, 0. And here, 0, right? So what did we learn from this? Well, it's interesting to actually see the activities that have slacks 0. Those activities with slack 0 are A1, A2, A4, A5, A8, A9, and A10. Those activities, we call them critical activities. Why do we call them this? Because if you delay those activities or they take longer than expected and than the time we designed them for, then the whole project will be delayed by the same amount of time. However, activities like A3, A6, A7 have slacks more than 0, and that means this activity, if it's not started on the earliest day but delayed by at most 6 days, or if it started on day 25 but it takes longer than 21 days that we expected, by at most 6 days, the project will not be delayed. Only when we exceed the 6 days of slack, or 4 days here of slack, or 2 days here of slack, we actually will start affecting project completion time 57. Right? So we will say critical activities are these, and also they form notice critical path. In some cases, critical activities may form more than one critical path, but in this case we have an easy example. So we could write we have a critical path that is A1, A2, A4, A5, A8, A9, and A10. That's our critical path. But the important thing from a management perspective is that these are critical activities. So if you're managing the project, if you want it to finish on time, in this case, let's say in 57 days, you better assign resources in such a way that you don't create delays, first of all, in those activities, right? The more slack you have, the less critical the activity it is, and then you can maybe um, focus your control on the critical activities a little bit more than on the non-critical activities. So this completes the calculation of earliest, latest start and completion times, and then finding the slacks and the project completion time, how soon the project can be finished at the earliest. We did this on a network, but we can also calculate these kind of things on in a table in Excel. Just one would have to be very careful when managing predecessors and successors. And when you calculate, remember, in the forward pass, the blue numbers, the earliest start finish times are calculated using max function when you have multiple predecessors. Like, for example, here, maximum of 23, 25, 27. And if you calculate in the backward pass the latest numbers, again, you have to be careful. If you have two successors or more, you have to take a minimum of the numbers 31 and 27 to put for the latest completion time. Why is the critical path so important? Well, the length of the critical path, you will see, is exactly equal to the earliest project completion time. What I mean by this is that if you take the activities on the critical path, take their durations, 9, 3, 7, 8, 10, 15, and 5, and you add them together, you will actually discover that the total duration of those activities is exactly 57 days. So this is the reason why the project's earliest completion time is 57 days. It's because there is a sequence of activities, each of, within each, within this sequence, each following activity requires the preceding activity to be finished before its start of the following activity, right? And so on. So A2 after A1, A4 after A2, and so on, up to A10, right? And the total time of those activities which have to be performed sequentially is 57 days. That's why the whole project takes 57 days. Notice you could look at other paths. For example, we can see A1, A2, A4, and instead of A5, I'll take A6, and then A8, A9, A10. And this path will have a shorter total time, right? Because instead of taking 8 days, I'm now taking 6 days here. So this path will have 55 days. And this is another path, which I would call non-critical, right? And any other path that involves some non-critical activities will always have the total time shorter than 57 days. So this is also a kind of explanation that is necessary for you to understand why the project completion 57 days is actually so many days. It's because of the sum of the durations on the critical path. Why delay in any critical activity will increase the critical path, right? The reason for this is that if this is the sum of processing times, if you add to any processing time here something, you will add to the sum 57. If you delay, like if you don't start this at as early as possible, meaning on day 9, if you delay it by 1 day, start it on day 10, everything afterwards will be delayed, and this will become 58 days, right? So you will finish the project 1 day early for delaying any critical activity. And the same way, you will understand that if there is 2 days of slack, these 2 days means actually that the path of going through this, the longest path that goes through this this activity is actually 2 days shorter than the critical path. And therefore, if you delay starting this by a day or two, right? If you don't start it on day 19, but you started on day 20 or 21, or alternatively, if you start it on day 19, but take 1 or 2 days longer than 6, you are still not going to delay the whole project. Similar analysis could be done for activities A3 and A7. And just one more word of caution, the slacks are not independent. So it might be that, for example, the delay here by 2 days and delay here by 4 days are fine. They will not delay the whole project. However, it might be that one delay, for example, delaying this by 2 days and then delaying this also by 6 days might actually cause the delay in the project because these slacks are kind of overlapping flexibility, right? You can only use a slack of one activity to the maximum with confidence that you will not delay the project. But if you use multiple slacks, you might actually remove some slack of the following activities in the project.